I'd like to thank PV Library, all the staff who have worked hard, Linda, Emily, and Dori Medina, all of you. Thank you so much. Engineering has many specialties, and I'm going to start with listing some of the specialties. Like civil engineering is one of the fields which helps in designing housing, highways, and freeways. So civil engineers are very helpful. And then mechanical engineering is a second field. It has, like, for example, the heating, air conditioning, automotives, robotics. They all come under mechanical engineering. Then you have electrical engineering, which has power plants of the electricity, and they design electrical products. Then there is architectural engineering, and architectural engineering is the one who gives the concept of a building. Like this building was just a concept at one time, and the board of directors of the library, they just explain what they want, and then the architecture gives the concept. Then the civil engineer comes afterwards, and he finishes the design drawings for the building. Then we have aerospace engineers. There is aircraft engineers and the space engineers. I have some examples of models. I'll go over, and you can also see them later on about the aircraft, how it evolved, including space shuttle also. Then we have next category of engineers is chemical engineers. The chemical engineers include petroleum engineers, even like simple things like the paint which we see the painted wall. The paints are designed by chemical engineers. Then we have environmental engineers. They are working on air pollution, water pollution. So they are very important elements of engineering. Then we have computer engineers like laptops, and we have IT professionals in the computer field. They are both in hardware and software engineers. Then there is another engineering field which is called industrial engineering. And industrial engineering, they work with automation, assembly plants, all the industrial efficiencies improvement they provided. Then we have biomedical engineers. They design prosthetics and artificial limbs. They work with the medical doctors and orthopedic surgeons. The next one is agricultural engineers, and they are working with high yield crops, and including the genetics nowadays. You have heard of GMO. They are working on the advancement of high yield crops. Then we have nuclear engineers. The nuclear engineers, they again are involved in both on the power side as well as on nuclear medicine. Then another category is geology and mining engineers. Then we have marine engineers who work on oceanography. The ocean is 2/3 the area of Earth, so ocean is also a very important area where these oceanographers are helping in designing different products for them. Then we have materials engineers. Materials engineers are developing new materials all the time. Like these airplanes used to be built with aluminum. Now you will see some of the airplanes are composite skins. The boards are fiberglass boards, and all these materials which are coming up are being developed by the materials engineers. So even a place like Hollywood, they use sound engineers for the movie cameras, and they design the movie cameras also. All of these are in the entertainment field. Then we have high-tech Silicon Valley and in Northern California. They are full of hardware and software engineers. So look at this library building itself. It was originally designed by an architect. Then civil engineers come in. Then mechanical engineers came and put elevators in this building. And then we have lights arranged by the electrical engineers and the computers projecting on the screen, or the IT people. They're also computer engineers. Let me talk about engineering as a field. You know, the heart of engineering is problem solving. So big problems are broken into smaller problems, smaller workable areas, and then its major tool is physics and math. So engineers use physics and mathematics for modeling. So first thing they do, engineers are analyze. They dissect the complex, challenging problem, and then they conceptualize into smaller components. Then they start applying mathematical relationships to describe important characteristics. After that, the number 3 step is to use simulation models. They fine-tune the system with simulation models. I remember when the library had a model here, the library building, the architect had built a model, it used to be here a few years ago, and that's how the model was built first, then it was built into a real library. So that's the simulation model. And the last one is the synthesis, which is the final step where you assemble all the small components. So, but engineers need both communication skills and problem solving skills. Just problem solving is not enough. They have to communicate with the customers, with the people who need solutions, and they cannot just sit in a corner and work on their problem. They do not design anything by trial and error. You know, that was the old concept. But now engineers, they do extensive modeling and they apply common sense to solve the problems. What are the new challenges for engineers now? The global warming is a big challenge. So the engineers are involved in global warming and population growth. Continuing the energy demand, and then there is we need to have sustainable growth. If we engineers design for growth, it also has to be sustainable and maintainable. They are looking at biofuels to replace fossil fuels, and then automobiles. They have basically the future automobiles will be basically computers. And I have this picture here of the automobile where when you are driving, the automobiles will be talking to other automobiles in a way that there is no collision. So they will be scanning other drivers. And the back side of the automobile, the rear side will be like an entertainment center. It will have all the entertainment you need. And then it has all the security features. All of these are going to be built into automobiles. There is even a rumor that Apple computers will go into automobile business because there will be so much computers in automobiles that they will need computer engineers to build automobiles. There are a lot of women engineers now. So the women are entering in the engineering field in big numbers. When I started in engineering, there were very few women engineers. But just to give you an example, I just brought this thing. Like look at this big roof. You know how there is no column in the middle. Like for example, if you want to support this roof, you know, then you have a column. Only one column can support this roof, but we don't have a column. So how does the load get transferred? So all these walls which you see around here, they are taking the load. But then on this side there is no wall, there is no glass. So when you open the window, you will see there are columns there outside. So they are supporting this side load. So these are the principles of engineers analysis. They design accordingly. After my presentation, you're welcome to look at the 747 and other models here. This is the B2 model here. This is the FAD fighter. This is Lockheed 1011 and this is 747. The original airplane also had a prop jet. So they used to go with the turbo fan. But now with the new technology, you have jet engines, which are much efficient and faster. I have some information about space shuttle here, so please feel free to come back and look at it. And if you have any questions, please feel free to ask me. I'll be around.